Hello, my dear students. Uh, Welcome to our channel, Easychemistry. And today, our topic of discussion is a reversible reaction. Now, we are going to discuss the kinetics of the reversible reaction. So, what is the reversible reaction? That is A to B. This is a sign of the reversible reaction. And what is the reversible reaction? So, reversible reactions are basically called opposing reaction. This is are basically called opposing reaction. So opposing reaction means the reactions are those, the reversible reactions are those in which both forward and backward reaction takes place simultaneously. Both forward and backward reactions are taken place. Both forward and backward reactions are taken place simultaneously. Number 3, at the start the rate, so number 3, so what is the A to B? This is our forward reaction. This is our forward reaction, and let the rate constant of the forward reaction is the Kf. So what is the Kf? Kf is the rate constant of forward reaction, and this is the backward reaction. So this is Kb, this is the backward reaction. And what is Kb? Kb is the rate constant of backward reaction. Okay, so for forward reaction, A is the reactant and B is the product, and for backward reaction, B is the reactant and A is the product. And when the time is 0, at the initial time rate of the forward reaction is very large and it diminishes as the concentration of the reactant decreases with the time. Okay, on the other hand, what happened initially, the rate of the backward reaction is slow. So what we can write, at initially, at initial time, rate of forward reaction is high and it diminishes with the time. It diminishes with the time, and as the time progress, rate of the backward reaction begins to increase. Okay, so number fifth, as the time progress, the rate of backward reaction start increasing. Okay, and very soon, a stage is reached where the rate of forward reaction becomes equal to the rate of backward reaction. So this stage is called equilibrium. So at equilibrium, there is no net change of concentration of any species. It can be reactant, it can be products. So there is no net change of the concentration of any species present in the system. So at equilibrium, what happen at equilibrium? This is the forward reaction, rate of forward reaction should be equals to the rate of backward reaction. This is the equilibrium criteria. Okay, and so actually it does not mean that at the equilibrium at the equilibrium no at the equilibrium no pieces are being formed or no pieces are being destroyed. It doesn't mean, but at equilibrium the formation of the pieces and as well as the destruction of the pieces are occurred in a simultaneous way with the equal rate. So at the equilibrium there is no change, no net change of the concentration of any pieces present in the system. Such type of equilibrium is called dynamic equilibrium. This equilibrium is called dynamic equilibrium. So what is dynamic equilibrium? I repeat. So in dynamic equilibrium, at the stage of equilibrium, all participants of the reactant are being formed as fast as they are being destroyed. So at equilibrium stage, what is dynamic equilibrium? At at equilibrium stage, at equilibrium stage, all participants, all all participants of the reaction are being formed are being formed as fast as they are being consumed. They are being consumed, and hence no further change of the concentration of any participants. So a reversible reaction may be classified on the basis of the order of elementary forward and backward reaction. So this is basically the forward reaction, and this is basically the backward reaction. So now we are going to discuss a special kind of reversible reaction. This is the forward reaction is of first order and backward reaction is also of first order. So uh, first of all, the first order reaction opposed by first order, that A to B, this is K forward, KB, and both the forward and backward reaction are of first order. Both the forward and backward reactions are of first order. Okay, so what will be the rate of the reaction? Rate of the reaction is the rate of forward reaction minus rate of backward reaction. This is R rate, and this is rate constant. Okay, so we assume that the reaction, forward reaction and backward reaction, both the reactions are of first order. So what will be the rate of the reaction? Rate of the reaction in terms of reactant, what happened? So it gives dA by dt, and in terms of product it becomes dB dt, and it becomes Rf minus Rb. Now, now let us assume the forward reaction only. Let us take the forward reaction. Take the forward reaction AB. So this is K forward and the rate is Rf. So what happened? Rf equals to Kf into concentration of A to the power 1, because for the forward reaction A is the reactant, and in case of the rate equation the power of the concentration of A will be 1, because we assume that both the reactions are of first order. And in case of the backward reaction, in case of the backward reaction, B is the reactant and A is the product. So here RB will be KB into B. So what will be our rate? So what will be the rate of the reaction? Basically it becomes R equals to dB Kf into A minus Kb into B. Okay. So my dear students, please write down the notes. Please write down the notes. Okay. So if x equals to extent of reaction at time t, t is the x is the extent of reaction at time t. So I'm going to remove this. So what happened? So concentration of A, this is the concentration of A at time t. This is A0 minus x. So what is A0? A0 is the initial concentration of A. A0 is the initial concentration of A. What is A0? Is the initial concentration of A. And the concentration of B will be x, because x is the extent of the reaction. So what happen if we in derivative A in terms of dt, it becomes dx by dt. Okay, so it gives kf, and compare this equation, compare these two equations. This gives a0 minus x, where in case of in place of a we put a0 minus x. So the value of a equals to a0 minus x. So and it gives, and for b it gives kb into x. So this is our main equation. Now we want to integrate this. Now at equilibrium r forward equals to r backward, we all know. So at equilibrium, in case of a, it will be a0 minus x equilibrium, because here x is the extent of the reaction, x is the extent of reaction at time t, and here x is the extent of reaction at equilibrium, and our assumed time t and equilibrium time cannot be or may not be equal. So here, for clarification or for more clarity, we assume the extent of reaction at equilibrium is different from x, so it is x equilibrium. So that is kb x equilibrium. Okay, so what is kb actually? Kb in terms of kfa, this is a0 minus x equilibrium by x equilibrium. So substitute the kb here, substitute kb here. So what we get, dx dt equals to kf a0 minus kf this. Okay, and from here we get dx by dt. So here dx by dt equals to it becomes kf a0 x equilibrium into, so this is our main equation here. Try to write down the equations, my dear student, please try to write down the equations. So what we get in our last equation, dx dt equals to, in our last equation we get dx dt equals to kf into a0 by x equilibrium into x equilibrium minus x. So separation of variables, all the variables with x will be separated from other variable, that is t, and this is t. And here, my dear student, here the x equilibrium is constant, so try to integrate from 0 to t, and it from x varies from 0 to x, x varies from 0 to x. So after integration it gives ln x equilibrium by x equilibrium x equals to kf a0 by x equilibrium into t. So it can be used to determine the values of kf from easily measurable quantity. These quantities are easily measurable, so that is a0, x equilibrium, etc. Okay, so alternatively what happened, we know that we know that we know that at equilibrium what happened, at equilibrium a0 equals to kb into x equilibrium. So kf into x equilibrium, kf into x equilibrium, kf into x equilibrium, or x equilibrium by a0 x equilibrium equals to, what does it implies, kf plus kb by kf. So it becomes ln x equilibrium equals to, in case of a0 by x equilibrium, we right? Kf and kf cancel, kf kb into T. So this is our final form. This is our final form where the ln x equilibrium equals to x equilibrium minus x into kf minus kb. So this is our equation. I am requesting all of my dear students to please write down the notes. Please write down the notes. Okay. So, my dear student, today we should stop here, and in our next class we'll see some more important topics, and we will discuss some more important topics. Till then, goodbye. Have a nice journey.